This is lesson 7.2, multiplying powers with the same base. You can use a property of exponents to multiply powers with the same base. For example, 3 to the fourth power times 3 to the second power equals 3 times 3 times 3 times 3, which replaces 3 to the fourth power, and 3 times 3, which replaces 3 to the second power. We can simplify this by saying that equals 3 to the sixth power. When you multiply powers with the same base, all you have to do is add the exponents. For example, 12 to the fourth power times 12 to the third power. Since these both have 12 as the base, all we have to do is add the exponents and we get 12 to the seventh power. Another example is negative 5 to the negative second power times negative 5 to the seventh power. It doesn't matter if you have negative or positive exponents, as long as we have the same base, you just add the two exponents and we get negative 5 to the fifth power. When variable factors have more than one base, be careful to combine only those powers with the same base. For example, 4z to the fifth power times 9z to the negative 12th power. By commutative and associative properties of multiplication, we take 4 times 9, which simplifies to 36, and then we can do z to the fifth power times z to the negative 12th power. Since both of them have the same base, we just add the exponents, and that'll equal z to the negative seventh power. By definition of a negative exponent, we can rewrite this expression as 36 over 7z, z to the seventh power. Here we have 2a times 9b to the fourth power times 3a to the second power. Again, by commutative and associative properties, we take the numbers, multiply those out, and we get 54. A and a to the second power we can multiply. When there's no exponent, we know that the exponent is 1. So we do a to the first power times a to the second power, add those exponents, and we get a to the third power. B to the fourth power has nothing to multiply by, so that just stays by itself. Exponents can also be expressed as fractions. Fractional exponents are called rational exponents. Recall that 3 to the second power means 3 times 3, which equals 9. You can write the same expression using rational exponents. For example, 9 to the 1/2 power. This is a fraction as an exponent. The equation 9 to the 1/2 power equals b. Indicates that b is the positive number that when multiplied by itself equals 9. Well, we know that 3 times 3 equals 9, so 9 to the 1/2 power equals 3. In general, a to the 1 over m power equals b means that b multiplied as a factor m times equals a. Remember, this 1 over m is a fraction in the exponent. So we're going to try simplifying 81 to the 1/4 power. What we need to think here is, because our denominator is 4, we need to think what number, when multiplied by itself 4 times, will give us 81. And we know that number is 3, because 3 times 3 times 3 times 3 will equal 81. You can also have expressions like 9 to the 3 over 2 power, which means 9 to the 1/2 power times 9 to the 1/2 power times 9 to the 1/2 power. That is because, since we have the same base, if I add 1/2 plus 1/2 plus 1/2, I get 3 over 2. Consider each factor individually. Because 9 to the 1/2 power equals 3, we can substitute 3 for each of these factors, and we get 3 times 3 times 3, which equals 27. So 9 to the 3 over 2 power equals 27. Let's try 64 to the 3 over 2 power. Again, 3 over 2, I can get that by adding 1/2, 1/2, and 1/2. So I can rewrite the expression as 64 to the 1/2 power times 64 to the 1/2 power times 64 to the 1/2 power. Each of these factors I know is equal to 8, because 8 times 8 will give me 64. And now I substitute 8 for each of these 64 to the 1/2 powers, and I get 8 times 8 times 8, and I get 512. You can use the properties of multiplying powers with the same base to simplify expressions with rational exponents. Simplify the expression 2a to the 2/3 power times 3b to the 1/4 power times a to the 1/3 power times 5b to the 1/2 power. By commutative and associative properties, I pull all the numbers out and I get 30. A to the 2/3 power times a to the 1/3 power. Since they have the same base, I just add the two fractions, the two exponents, and I get 3 over 3 as my exponent, which is equivalent to 1. And any number to the first power is always that number itself, so we get a. And then b to the 1/4 power times b to the 1/2 power. Since we have the same base, we combine 1/4 plus 1/2, and we get 3/4. So our simplified expression is 30a b to the 3/4 power. Here are some sample problems. What is the expression 9 to the negative third power times 9 to the second power times 9 to the sixth power written using the base only once? Well, since we have the same base, we could take 9 as our base, and all we have to do is add the exponents. We have negative 3 plus 2 and plus 6, which will equal 5. So we can rewrite this as 9 to the 5th power. Here we have negative 4c to the 3rd power, 7d to the 2nd power, and 2c to the negative 2nd power. And we could take all our numbers out here. So negative 4 times 7 is negative 28 times 2 is negative 56. C to the 3rd power times c to the negative 2nd power. Well, I'm going to do the work on the side here. C to the 3rd power times c to the negative 2nd power. Well, since I have the same base, I could just add the two exponents. 3 plus negative 2 is just 1, and c to the first power is just c. So I'm going to write c here. And d to the 2nd power has no other factors that I can multiply it with, so I just leave it like that. So our simplified form would be negative 56c to the times d to the 2nd power. Here we are going to try simplifying 16 to the 1/4 power. Well, let's think about this. Since our denominator is 4 in that fraction, we need to think what number multiplied by itself 4 times will equal 16. And if you think about your numbers, you should get 2, because 2 times 2 times 2 times 2 will equal 16. Here we have 25 to the 3 over 2 power. Well, 3 over 2, I can rewrite this expression as 25 to the 1/2 power times 25 to the 1/2 power, oops, times 25 to the 1/2 power. So I'm just going to make these multiplication signs. Okay. Well, I know 25 to the 1/2 power is equal to 5, because 5 times 5, since I'm only looking for two numbers, number multiplied by itself twice, that'll equal 25. I can replace the 25 to the 1/2 power with that 5, replace this one by 5, and replace this one by 5. So this will simplify to 1/25. Here we have the expression 2c to the 3/5 power times 2c to the 1/5 power. Again, I can take my numbers, multiply those out. Here I have c to the 3/5 power times c to the 1/5 power. Since they both have the same base, all I have to do is add the exponents. So my base will be c, and I have c to the 4/5 power.